Assalamualaikum and hi. My name is Muhammad Anas Hakimi bin Masaat from Group 10. In this video, I want to talk about a technique of differentiation. First of all, I will introduce my other group member. First, my other group member is Muhammad Hamis Akhtar bin Azul. And for my second group member is Muhammad Aziz bin Muhammad Haziz. We are from Group 3. So, the first thing I want to talk about is the sum and difference rule in differentiation. This technique provides a systematic way to differentiate function with multiple terms. They are commonly applied so often in calculus that we often use them naturally without ever thinking about it. And then, we also have product rule. In this section, we explore how to differentiate more complex functions, especially those stated as the product of basic or standard function. The ability to differentiate such function depends on applying specific differentiation rules. Third, we have a constant rule. In this section, we consider function in the form of y equal to fs over gx. To find the derivative of this function, we must apply the constant rule. And lastly, we also have implicit differentiation. This section introduces implicit differentiation, which is used when the function is not explicitly solved for one variable in terms of another. For question 1, the question asks us to explain the meaning of differentiation and what are the techniques of differentiation. For the meaning of differentiation, differentiation is a process of finding the derivative of function which represent the instantaneous application a function might. For example, represent the strength of motor magnetic field, the voltage across a capacitor, the temperature of a chemical mixture, and it is often important to know how to quickly these quantities are changing. For the definition of derivative, we use the formula lim h to 0, f in the bracket s plus h minus f in bracket s over h. And then for the technique of differentiation, we have 6 techniques, which is sum and difference rule. First technique, product rule. Second technique, quotient rule. Third technique, chain rule. Fourth technique, implicit difference for the fifth technique, and linear approximation for the sixth technique. For question 2, the question gives us two questions and asks us to find the dy dx for the following function. So, I will do the first question first. For the first question, the question is f in bracket x close bracket equal to 3x squared sec in bracket x plus 2 close bracket. So, to answer this question, first we need to change the equation to the another terms, which is u and u prime, v and v prime. U prime and v prime is the differential form for the u and v. So, as we see here, u is the 3x squared and u prime is the 6x after differentiation. For the v is the sec in bracket x plus 2 and v prime is the sec in bracket x plus 2 close bracket tan in bracket x plus 2 close bracket is the differential form for the sec in bracket x plus 2 close bracket. And then after we divide the term, we use the product rule, which is d over ds in bracket uv close bracket equal to u prime times v plus u times v prime. So we just type in the equation that we divide just now into the formula, which is d over dx 2 times v, which is 3x squared times sec x plus 2 equal to 6x times sec in bracket x plus 2 close bracket plus 3x squared times sec in close open bracket x plus 2 close bracket tan open bracket x plus 2 and close bracket. After we sub in the formula, we just have to simplify the question. We just have to simplify the equation. So we will get the answer, which is 6x sec open bracket x plus 2 close bracket plus 3x squared sec open bracket x plus 2 tan in bracket open bracket x plus 2 close bracket. That is the answer for the question 1. For question B, we get the question is y equal to 4s plus 2 over cos s. Just like the other question just now, we just have to divide the question into the u and v term, which is u is the 4s plus 2 and the u prime is 4 after differentiation. For v equal to cos x and v prime is negative sin x. In this question, we will use the quotient rule, which is the formula is d over dx in bracket u over v in cos bracket equal to v times u prime minus u times v prime over v square. After we write the formula, we just type in the number that we did just now, which is dy over dx equal to cos x times 4 negative 4x plus 2 times negative sin x over cos x square. After that, we just have to simplify the equation and then we will get the answer, which is dy over dx equal to 4 cos x plus 4x plus 2 sin x over cos x square.
Let me move on into question 3. Given y ln 3x minus e power of 2x plus 1 minus tan 4y equal to 0, find dy per dx using implicit differentiation. So, first step, differentiate the both sides with respect to the x. Let's start with the first term, y ln 3x. Here, we will use the product rule which say uv prime equal to u prime v plus uv prime. So let's treat u equal to y and u prime equal to dy per dx. V equal to ln 3x and v prime equal to d per dx ln 3x. So by using the formulas, we will get dy per dx multiply ln 3x plus y multiply d per dx ln 3x. Now, the derivative of the ln 3x is 1 per 3x multiply 3 and will become 1 per x. So this will become dy per dx multiply ln 3x plus y per x. So next term, we will apply the chain rule. Derivative of e power of 2x plus 1. It itself times derivative of 2x plus 1, which is 2. So it will become a negative 2 e power of 2x plus 1. So for the last step, for a negative tan 4y using a chain rule. So it will become a negative sec power of 2 4y multiply d per dx 4y, and it will become negative 4 sec 2 4y multiply dy per dx. So lastly, put everything together and it will become dy per dx multiply ln 3x plus y per x minus 2e power of 2x plus 1 minus 4 sec power of 2 4y multiply dy per dx equal to 0. And then group the dy per dx terms and it will become ln 3x minus 4 sec power of 2 4y multiply dy per dx equal to 2e power of 2x plus 1 minus 1 per x. So solve for the dy per dx and it will become 2e power of 2x plus 1 minus 1 per x divided by ln 3x minus 4 sec power of 2 4y.
Assalamualaikum, my name is Momazi. I will explain how to do question 4. So question 4, my answer was to use a linear approximation to estimate a value of this equation and the final answer with 3 decimal place. So the first step was we must let our equation fx to switch the value of 18.99 with x. So just switch the two and we must change the set to power of in here and here. So in the final answer for this equation, we must bring up the x to the up. So it will become negative 1 over 2. Next step was to do differentiate to find f prime, and we will get this answer. So the next part was we must choose. So the given value for the x was 18.89 and the chosen value I choose was 81 for the SO because it closer to the given value and it was the same integer. So the formula for delta x was x is given value minus x ohm or chosen value. So 18.99 minus 81 and we will get negative 0.01. Next was to key in the formula for linear approximation. Fx f x ohm plus f prime x ohm times delta x. So just key in the equation in here both and we will get 2.778. That's all.